Welcome to my channel DevOps Mela. This is Rohit Singh, and welcome to my Kubernetes scenario based interview question with practical solution. All thanks to the comments and the emails which I have received. Because of you all, I'm coming up with part 2, guys. Okay, if anyone is new over here, I got a complete series on DevOps scenario based interview question. Please do check my interview question playlist. Okay. Let's get started. The question is, what are services? Explain different types of services in Kubernetes. Though this question is very straightforward, but there could be many more questions derived out of it. Like for example, I got my application running inside a Kubernetes pod. How do I access my application from internet? I got my front-end server running in one node and I got my backend database on other node. How do I enable communication between these two pods? How do I enable communication, internal communication between two pods? So these could be various scenario-based questions which can be derived out of this question. Okay, so let's see what is. And before I start talking about, I do have my Kubernetes cluster up and running. Okay, I do have all my nodes up and running. Again, I've set up this cluster using an automated shell script which I have created. So this is an automated shell script. You'll find this shell script inside my description box. Please do check. And if you want to know from scratch how do we set up a Kubernetes cluster using Kubeadm, I do have a video on it. Please do check the video in the video link in the description box. Okay, so let's get started. Let's go back to the PPT. What are the different services and what exactly is services in Kubernetes? Now, Kubernetes service enables communication between various components within or outside the application. For example, if you want to enable communication between two pods, you need to have a service object created. If you have a web server and if you want to access those web server from internet, you need to have a object created. So basically, service will help you enable the communication between the Kubernetes pods. Okay, so there are various three types of service in Kubernetes. The first service is cluster IP. The cluster IP facilitates internal communication with other apps in your cluster. No external access, and it's the default Kubernetes service. So basically, within a node, if you have two pods running, just imagine this is web server 1 and web server 2, and if you want to enable communication between these pods, then you will be using the cluster IP service. The other one is node port. Node port, basically what it will do, it's open a specific port at the node level. So if you see, this is the port and all the traffic. So suppose the communication is happening from internet. So the request will come on this port, then the request will be redirected on port 80. Imagine this is Nginx. Okay, so what node port does, it opens a specific port on the node and forwards the traffic to the port via service. Port to choose, so this is the range 30,000 to 32767. This is the range within which you can select the port. Okay, now this is one way of accessing your application from internet. One more example I'll give you for node port. Imagine there are node 1 and node 2. In node 1 you have your front-end web server, and in node 2 you have your back-end web server. And if you want to enable communication from your front-end application to your back-end, over there also you can use this node port option. Okay. Third but not the least, load balancer type. So load balancer, which will route the traffic from the external service. So basically this is a standard way to expose your application to internet. Now this is a standard way to access your application from internet, guys. So it's a load balancer type. So imagine you have two ports on which your web server is deployed. So this load balancer type service will distribute the traffic, okay, accordingly. And with this load balancer type, you will be able to access your internet, you will be able to access your application from internet. Okay, so these are the three types which you will come across. Now let's do one thing. Let me show you in practical. So if you want to create a service, now this is the YAML file for creating service, very simple and very straightforward. This is a API version kind, and the type which you can specify, load balancer type. Similarly, you can have node port, you can have your cluster IP. Remember, cluster IP is the default Kubernetes service. Let's go on the terminal. Now what I'll do, I'll quickly create a pod and I'll show you how do we assign or create services. Okay, let me create a pod image Nginx, and let's give it a name, Nginx-web app. Okay, so I do have a cluster, Nginx cluster up and running. Can we access this cluster? Can we access this pod? The answer is no. Okay, in order to access this port, what you need to do, you need to create a service. Okay, to access the port, we need to have a service created. We'll be creating a node port type service. Let me show you how exactly it is created. In order to create using declarative, so this is the declarative template which you can use if you want to create a type load balancer, but in my case I'll be using the imperative commands. So I don't remember the command, guys, so I'll simply do kubectl expose. Guys, I'm using alias, so my kubectl is set to k. Okay, in case if you're wondering what this k is all about. So k expose, my pod name is Nginx web app. The port I want to expose is port 80. The target port number will get assigned automatically. The name of the service, I want to keep it as SVC Nginx. And the type, as I said, there are three different types: cluster IP, node port, and load balancer. So I'll be sticking with node port. Okay, exposed. Now let's quickly go and see. Okay, get all. So I do have a Nginx service created and the type is node port. If I want to access my web server, very easy. I can just simply do curl http localhost and the port number is 31169. Okay, see, I'm getting my Nginx page. Internally the routing will be done on page on the port 80. Okay, so this is how you will be able to create your services. This is how you can access the application running inside your pod using all these services. Okay, so let's get started. Let's see what's the next question. Okay, the question is, how do we monitor Kubernetes cluster resources? Now again, looks very straightforward question, but you need to ask various questions like, what exactly do you want to monitor? Do you want to monitor the load level metrics, like check if the nodes are healthy? Do you want to monitor the performance level metrics like CPU, memory, network, and disk utilization? Or do you want to monitor the pod level metrics like the health of the pod and the performance level metrics of pod like CPU and memory? Okay, so there are various tools. Okay, tools such as metrics server, it's a Kubernetes metrics server. Prometheus, it's again an open source. Dynatrace, Datadog, Elastic Stack. So there are many monitoring tool available in the market. Today, the one which we will be talking about, metrics server. That's comes with Kubernetes itself. All others are third-party tools. So let me know in the comment box if you want to know how do we integrate Prometheus, and how do we integrate Grafana and all. So I'll have a separate video created on that. Today we'll see how this metrics server out of the box works with Kubernetes and what exactly is metrics server and all. So metrics server, Kubernetes metrics server is a cluster wide aggregator for resource usage data. Okay. The metrics server retrieves metrics from each node and pods, aggregate them and store them in memory. Okay. So what exactly the metrics server does? It retrieves metrics from each nodes and pods, okay, aggregate them, and then it typically stores those information in memory from where you can fetch. As a result, it doesn't store historical data because it's stored in memory. If your server on the node is restarted, the data is gone. Hence, we cannot use metrics server for production level clustering. Okay, so why exactly I'm covering? Because this comes binding with Kubernetes, guys. That's why I'm covering metrics server today. But do let me know if you want to know how Prometheus and things work. I can possibly have a separate video created on that. Now, what exactly metrics server does? Okay, it uses kubelet for fetching data. Okay, and then using the C advisor, container advisor, it makes the metrics available for the cluster. How exactly it works, let's go and see. Now, in order to set up metrics server, we can make use of this GitHub, official GitHub repository of metrics server. And if you come down, there is an installation process. Okay, so let's go and copy this part and let's run it on the server. So we are basically setting up a metrics server. Now when you run this, there are multiple things gets created: a service account, various roles, a deployment, and API registration. Now where exactly it got created? So it all got created in a kube system namespace. See, if you see, we got a pod running metrics server, and we do have a deployment created for metrics server. Okay, but it's not running yet. Okay, so the reason it's not running, we need to make certain change into the deployment file of metrics server. Let's go and edit that first. Go and edit the deployment of metrics server. Let's add few commands in it. Okay, so here we go. Let's come to the container section. Okay, let me copy paste what exactly I want. So these are few commands which I want to add. So let's paste it. Perfect. The deployment file got edited successfully. Now I should see one more metric server pod got executed. Let's wait. So guys, this will take pretty much time to fetch those metrics. Okay, now let me see if my metrics server is working. So in order to check, you can simply run the command kubectl top. So let's see what all options we have. So we got kubectl node and pod. Let's see if we are getting any metrics now. So kubectl top node. See, I just got one single node, and I'm able to see the CPU, the memory utilization for my node. Similarly, if you have any pod running, it will give you details regarding a pod as well. But there's no pod in this namespace, but I do have pods running in my kube system namespace if you want to check. See the amount of CPU and memory utilization by pod. So this was the second question from my deployment series, for my Kubernetes series, like how do we monitor? We have seen it the various way, but the tool which we saw in this question was metrics server. That is a Kubernetes metrics server. Basically, it will give you information about node and pod performance. Okay, but it store data in memory, so definitely cannot be used for production. Okay, just keep that in mind. But do let me know if you want to know more about how do we integrate Prometheus, Grafana and all. I'll try to get one more video created on that. Okay, let's move on with the next question. Very interesting question, guys. How do debug specific container logs? Consider there are two containers running inside a single pod. Very interesting question. Suppose in a pod there are multiple containers running. How to check logs of each container? Now we all know that if we run a command kubectl log and the pod name, we get the complete logs. But how do we make sure like which container logs it's displaying right now? So if you want to know multiple container logs, so you need to specify the container name. Okay, so kubectl log -f and the pod name. With the container name, you can see specific container logs. Okay, let me demonstrate this for you. Then it will start making more sense. So what I'll do, I have a YAML file which is creating a pod, and it is creating two containers. One, the first container, it has an Nginx image which will be running on port 80, and it got a second container, again the same Nginx image, but it will be running on port 81. Now in order to run two containers on a different port, we need to have two different config DID. So this container will take the default config DID. For this container, we'll have a config DID mounted. So this is the command, this is my config file. The only thing I made changes, the listener port I have changed from 80 to 81, guys, nothing else. So let me just copy this. And let me go back to my terminal and let's create default.config file. Default.conf file, paste it. Okay, post that, let's create a config map. I'll be using a config map over here. So kubectl create config map, and let's give it a name, Nginx conf, and let's use the file what we have, default.config what we have created. Perfect, I have a config map created. Let me verify kubectl get config map. So we got nginx.conf created. Now let me go and run my dual container YAML file. Let me copy this all, come back, and let's have a dual.yaml created. Dual.yaml created, and let me run this. So basically what it will do, it will go and create my first container, and it will create my second container. The only difference will be the second container will be created using the config what we have created. Okay, let's go and run it. Kubectl apply -f dual.yaml. Perfect. Now let me run the command kubectl get pods. I have one pod created, and in that pod, if you see, there are two containers. How do we verify? I can do a quick describe pod, and we can simply use the pod name. Okay, now come down. This is my first container running on port 80, and I got my, at the bottom I should see my second container running on port 81. If you want to verify, if you want to access the web page, you can simply do a kubectl execute, and you can give a container's name, that is multi-container, and we can simply do a curl localhost. I can do it on 81 once. So I'm seeing a Nginx page. Welcome to Nginx. Similarly, if you want to see 80, again you will see the Nginx page. So we got a running multiple containers inside a pod. Now coming back to the PPT question, how do we check logs? So usually we can check logs by running this command kubectl log -f, and you can give the pod name. Oh, sorry. So it should be logs, not log. Let me update my PPT as well. Okay, logs. So I'm seeing my pod logs, but I'm not sure which container logs it is displaying. I need to be very specific. So for that, what I can do, I can, in place of multi-containers, I can also put the container name. So what is the name of a container? So this is my first container. So let me copy this part, come back, put it over here. Now see guys, I'm getting my first container logs. Similarly, if you want to have your second container logs, let me copy the second container name. You can also have your second container logs. Okay, this way you can check specific container logs. That is what the question was. How do we debug specific container logs? So it's kubectl logs. Guys, this is not log, it's logs. And you can give the pod name followed by the container name to find out specific container logs. Okay, hope that helps. Let's move on. Very interesting question. What are the different deployment strategy in Kubernetes? Okay, so interesting question. What will be your deployment strategy? Like if we got multiple pods running my application, what should be my deployment strategy? So in Kubernetes, out of the box, there are two different deployment strategy which you will come across. One of the deployment strategy is a rolling update deployment. Now rolling update deployment, give me one quick minute. Rolling update deployment is the default deployment strategy in Kubernetes. What it will do, it replaces pod. So what it exactly do, imagine you got your web servers deployed on these pods. So there are version 1 deployed on 4 different pods. What it will do, it replace pods one by one, depending upon, it will go and start replacing your pods one at a time. Now if you see, we got the version 1 got replaced with version 2, and we got 2 new pods created. So of the previous version of your application with pods, of the new version without any cluster downtime. So the benefit of using rolling update, it will basically, if there are 4 set of pods, it will go depending upon what max surge and things you have defined. Based on that, it will go start making changes for you. Okay, so in my case, 50% of pod was removed with my newer version, and my 50% of my pods is still serving my older version right now. So with rolling deployment, slowly replaces instance of the previous version of an application with instance of new version of an application. And once we get a confirmation that the new version is looking good, all the pods in the system will get replaced with the newer version. That is what rolling update deployment means. The other deployment, what we have, recreate deployment. Recreate is, in recreate deployment, we fully scale down the existing application before we scale up the new application version. So what will happen, all these 4 pods which is serving your web application will be dropped and new set of pods will be created. Okay, definitely we have a downtime with in this strategy. We do have a downtime wherein all your existing application is getting down completely and new set of pods are getting created. The benefits of using rolling update strategy is there is no downtime at all. Let's go and see it in practical. So I got this rolling deployment strategy over here. In this rolling deployment strategy, I'm creating 4 replicas. I'm creating Nginx web app. Now the strategy type is rolling update. Max surge is 1. Okay, and max unavailable is 1. Now what exactly is max surge? Basically it means the number of pods that can be created above the desired amount of pods during an update. Okay, it could be an absolute number or it could be even percentage. You can put percentage like 25%, 50%. 50% means 50% of your pod will be removed and the new version will be deployed on top of it. Okay, and max unavailable is the number of pod that can be unavailable during the process. So in my case I got 1 so that means 1 pods will be replaced one at a time. That is what a rolling deployment strategy is. So let's go and create this one. That's role.yml. Okay, let me run this. Okay, now if you go and see quickly, I got 4 pods running in. Okay, now if you go and see, there's one replica set also created for the rolling update because we got 4 replicas. Now what will happen if I make changes? What will happen in rolling deployment strategy? What will happen if we go and make changes? Okay, like for imagine I'm just, give me 1 minute what I'm doing. Okay, let me go and make changes. So basically what I'll do, I'll change the image. So let's do one thing. Let me set image. So I'm making changes to my pods now, guys. Imagine it's a deployment what you're doing. So I'll just change the, what is the name of my deployment? Let me copy this name, put it over here, and let me change the image from equals to Nginx. Okay, so I'm updating my Nginx image. Okay, updated. Let's quickly go and see. If you see, my replica set got updated. There's a new replica set got created, and slowly and steadily it will all get replaced. See, it all got replaced. I got new set of pods created in a new replica set altogether. Now if you go and see the events, how exactly it has happened, let's go and see the events of my deployment. So I can do a describe. See, at once all the 4 replicas were created, but when we made the image changes, you can see to 1, then scale down replica set rolling from 3 to 4, 2 to 1, 2 to 3. So one at a time, depending upon the max surge and max unavailable what we have defined in my rolling deployment strategy. Based on that, whatever we have defined, based on that, 1 pod at a time was brought down and the new version was applied to it. This way all the 4 replicas was 0. This is the old replica set, and now this is the new replica set, wherein 1 pod was bought down, then a new deployment was done on top of it. Okay. So that is an example of rolling deployment strategy. Same way, we can test a recreate deployment strategy. So only change you can find is I've written recreate over here. There's no max surge or max unavailable in recreate, so that was not recreate.yaml. Let's go and run this. Okay, now I do have recreate created. So we do have recreate deployment created, and we got 4 pods created for it. Now same strategy, I'll go and make changes to the image. Let me just copy the deployment name. Okay, let's go and run the command again. kubectl set image deploy, and I just change the nginx equals to nginx 1.14.2. So I'm just updating the nginx image. So the nginx image what we have currently defined, it's nginx 1.14.0. We are changing this to nginx 1.14.2. Let's see how it works. See, one more replica, a new replica set was created, but now this was done immediately. Okay, all the previous replica set was brought to 0, and then a new replica set was created with 4 new pods. Now what we can do, we can quickly go and check the events, the deployment event describe deploy, and if you see, this was when we have created, and this is when we made the changes. Now if you see, scale down to replica set to 0 from 4, then again all at once all the 4 pods were created. So these are 2 deployment strategy which you will come across when you're working with Kubernetes. Rolling update deployment strategy, there is no downtime. Okay, with recreate there is a downtime because your application is completely down, then the things are again redeployed. Okay, both the strategy has its own pros and cons. Now if you're going with rolling, then you might have to think about backward compatibility, forward compatibility. There are many things you need to consider. With recreate, you definitely need to take a downtime, because in recreate everything gets dropped, then it gets created. Okay, that was about strategies what we have in Kubernetes. Now let's go and see what is the next question we have. The question scenario question number 11, very straightforward question. What is a daemon set? Explain the use cases of daemon set. Now during an interview, the same question they can ask in different ways. Like one of the scenario is, I want to set up logging pods, logging server basically on each new node which gets created in the cluster. How can we achieve it? So the answer we all know now, it is daemon set, guys. Now what exactly daemon set does? The daemon set ensures that all nodes run a copy of pod. As nodes are added to the cluster, pods are added to them. Any new node which gets added to your cluster, automatically if you want to have some logging pods added or some monitoring pods added, it will get added automatically. As nodes are removed the cluster, the pods are garbage collector. Deleting a daemon set will clean up the pods if created. Now let's see some use cases. There are typical use cases. As I said, one is running a log collection daemon on every node, such as Flondy and Logstash. So if you want to run any log collection daemon, then this is the best way to do it. The other use case which I can think of, running a node monitoring daemon on every node, such as Prometheus node, exporter, collect Datadog agent. So if you want to have such node monitoring daemon added to each new node which gets added to your cluster, well and good. Third example, running a cluster storage daemon on every node, such as cluster D and chef. This is what Daemon said. It's a very useful service, and this is very useful when you want to achieve anything as such. Now, for an example, I'll take you to the official website for the daemon set Kubernetes. This is an example of Flondy Elasticsearch if you want to add as a daemon set. So if you create a daemon set, the kind is daemon set. Now let me go and create this for you, or else I can simply run this and it will go and create that for me. Let me show you how exactly a daemon set looks like in reality. Let's run this YAML. Now if you go and see, we got the daemon set created. Now where exactly it got created? It got created in Kube system namespace. Now if you come down, you have a daemon set created over here. Now if you go and describe this is a Flondy Elasticsearch daemon set which got added. Now if you see, it is running a pod also. Now we can route this logs using Kibana and all, and we can have a dashboard created. There are various ways to do it, but this is what daemon set will do. If you want some service to get to run on a newly created node, or a particular pod to run on all the nodes, then this is a classic example. Okay, the other example which you guys might be very familiar will be Kube proxy. Kube proxy is also a daemon set, guys. So this Kube proxy, which is also called a network proxy, it runs on every node which gets added to your cluster. It's a classic example of a daemon set. Okay, so that's it from part 2 of scenario based interview question. Now do let me know if you like this sessions, and please suggest if you want to have part 3. Okay, and please do like and subscribe to my channel, and please don't forget to watch the complete interview question playlist. I have more than 50 questions on DevOps. Please go and check my playlist. Okay, thank you very much. Goodbye.